All right, so a couple of corrections. I noticed this when I was looking at the early view, and we were kind of deciphering what was going on with this geometry. I'm still not 100% convinced that moving that arc was the right thing to do, but it makes it functional, at least for now. So it's in the back of my mind what it's doing. And let's see if we come to that drawing view. When we were going through that process, I kind of came back here and I looked at this and I went, there's no object line going across the face of this item. And what that means to me is that, let's go back to, and which one was that? That was item 3, the clamp. That means that I kind of missed something, that this terminates at this line. All right, so the fillets, let's see what it does. All right, so I'd rather have, again, the fillets at the very end. So I'm going to open up a sketch. And I think that when I built this, I just sent this all the way across with all of the geometry. We made several cuts, so it's not like I can just go and say, make that part a little smaller. Now, in the layout, I may be able to deselect that item, but I don't want to get too carried away with my geometry just yet. Alright, so if I can project into that plane, so this is a valid endpoint, and that being a valid endpoint, I can make those two coincident. And now that they are coincident, when I go into the features, we're going to Extrude Cut. And I can just give it an up to next so that it stops before it knocks the tops off of the arcs, and I have a little less there to deal with. All right, the other thing that I noticed, let's go ahead and roll the fillets forward and see if there is an error. So it kept the fillet, kept the relation. We'll jump back into this one. So while I was looking at the 3 7/8 for the arc, and we ended up making that 5" from the center line, I also noticed that this was 5.5, which may have been one of those. We'll figure that out later for the end place, and we'll go through each of the views. All right. So cut extrude 4, and that one does come up at 5.5. So. I did want to check that dimension. Might have changed that last time when I recognized it, but we'll go back and double check. And then, what was the other one I saw in this part? No, I guess that was it. Alright, so one of the things I'm trying to decipher on the assembly then, and going back to the early views with the cross section, is we have the spring, or we have a spring up here, and that looks like that plunger. So the question is, where do we put the hardware for these the sub-assemblies? That one also being a spring, and going back in, we can put it into this sub-assembly. Now let's go ahead and close that. And I'll open up the cradle item. Nope, that wasn't the cradle. Hand lever. Nope. Slide locator. Okay. And rebuild. All right. So we had one spring that is moving with the locator. And then we also had a spring that's moving with this guy. And the alignment almost looks like, so let's check the alignment. Go to a hidden lines visible. Well, if that one ends up at 5.5 and those numbers are actually correct, then my plunger spring is going to pretty much fall into the counterboard for the locator. So, kind of a problem. Let's see what it looks like in relation back over here. No, it's pretty much in line. So why would you put a locator above a socketed cap screw or above a screw? All right, so not real clear on that one. So next problem, let's go ahead and build in the springs. And so to clean out, let's see, did I create a display state? No. So add display state, and we'll single click, and this will be my work in progress, so that I can hit the tab button and make some of these at least jump out of the way. Alright, so I'm going to insert a spring, component, existing part and assembly. There are my springs. I'm not sure exactly which one I need yet, so we're just going to insert one. This will be rotation about Y. We get it lined up. And that one looks a little bit long since the bill of materials isn't quite as extensive. We'll need to right click, and that it was spring 30, which was compressed, and 17. We'll go over to 17 and hit the check mark. That one's a little bigger and fits a little bit better. So to locate, since we have the ground and flat ends, let's go ahead and make that coincident. We'll see if we're round enough to use the edge, and since it didn't pick up, that one's still not picking up in the mate for some reason. Alright, and so that goes into the location. Alright, so this is able to move back and forth. Since I put it in relation to the end of the locator part instead of relation to the slide, all right, in reference to, really it should be stopping there, and we'll see how much it's able to move. All right, so if I go back in and show the slide, what was the other one then? The cover. Okay, so if we get that one in position when it's all the way extended or all the way collapsed, we'll go into the front plane is bisecting the assembly. We'll go into section view, and in section view I'll be able to measure from there to there. And if I really want this spring to kind of show up in its fully collapsed state, I will go back and make a configuration for the smaller dimension. So item 17 compressed. All right, so I don't want to add a configuration or a derived configuration from this item. We want to be still at the top level. It's going to take the information from the current configuration, and then we'll do item 17. Let's see, what did I call the other one? Keep my naming consistent. So splitting the window, 17, spring, compressed. And then we'll go back into its dimension. And I think we got 1.27. And notice that with the modify box now, because there are configurations that we've set, that we've built in, you're going to have the ability to say, change this dimension at this configuration. Change this dimension in all configuration, or specify the configurations that you want to apply it to. So it's free state. And then we rebuild it. We'll see if it works. Okay. Alright, so that one becomes the 17 spring compressed, accept. And then now when I look at it in the cross section, pretty close. I may have missed a little bit, but not too bad. All right, so that's but that is going to be at its smallest, at its fully compressed. And then let's go ahead and just exit out of that. So when it moves out, not so much. Do I really care that it got another 1/8 of an inch there? At this point, not really. You know, I'm looking more for, will the coils go through the compression like it's supposed to? So that was going to be a bolt on that end, or was that another spring? I know that spring goes that way. We're thinking that the spring and plunger goes that way, or as part of the plunger. And then there was supposed to be one more spring somewhere. Alright, so let's go ahead with tab and tab. And then I want another spring, so let's just go ahead and drag one in. Holding down the control button on the item. And then let's see, what is 18? Nope, 18 is still pretty big. Yeah, it might fit in there, so let's try it. So that goes coincident. We'll pick up the edge, pick up the cylinder, make it concentric. And it fits in there. It looks a little snug, but it's doable. And oh, that one's still there. So let's go ahead and hide it. Alright, so the issue here is if the plunger fits in that like I think it does, which, you know, we don't have exactly the best directions, but I'm not seeing, you know, we had the other plunger, and we've accounted for most of the rest of the parts until we go up to, let's jump up, till we go up into this, and that kind of looks like it too, so I'm going to stay with that. And so this was one of the parts that I will zip and put up on canvas. And we'll grab the two bearings, I'll give you the springs, and I will give you the Creo part and now the inventor part. Alright, so existing part and assembly, we're going to browse, and the inventor file, we're going to be in all files so that it shows up, and we're going to keep our fingers crossed. So at this point, it has not been converted. I'm bringing it into the assembly. It doesn't exist as a solid part. So not surprising that it failed to open. So what I need is now let's just go ahead and do an open, and we'll bring in the inventor file. We're invalid, found or not incompatible type. Really? Would have sworn I opened that one up earlier. Maybe in 2018. Well, that's going to be annoying for the plunger then. I will have to try that again. Yep.
Space with something like plunger in space. Because I know Creo you need to use underscores.
Mm-hmm. Didn't think there was.
Oh, just the
As far as the folder name?
No. Well,
yeah, there was no space in the. But that, yeah. Oh, it's open. Well, it didn't open anything, but it still thinks it's open. That's nice. Okay. I want to say I ran that test, but I may have run that test in 2018 SOLIDWORKS, so we'll have to come back to that one. Alright, so that being the case, plunger is not really that difficult. I can draw it up real quick. Okay, come on. Okay, once I locate it, we can draw it up real quick. Alright, so it was drawn up in Inventor. It was intended to act as one of the imports, but apparently 2017 is not ready for it. So, that being the case, File New. And we'll go front plane. Let's see, this has a little bit of a dome, so sketch, center line, vertical, infinite length. And we're 5/16, so we'll go to about there, over, up. Draw the arc. Alright, so 0.312, and let it scale. Let's see, 625 on the shaft, and escape to get out of the diametral. Overall, well, we had 498, 497, so should put that one in first. 498. The overall then was 0.937, so 15/16. And then radius of 0.625. And actually that came in decent, and we have the radius. And, well, we kind of expected to come up with the tangency, but features, revolve base, and blind 360 is fine. And let's go ahead and save that as item 19 plunger, which hopefully I didn't name the other one. There we go. Alright, so with that still open, we'll go into the slide locator and insert components. The plunger is still open. Okay, if it'll let me have it. Either that, I'm getting ready to crash. No. It's not picked and it's not dragging out. So no, that should be okay. There we go. So I'm not sure why it blinked, but there we go. Rotation then, let's go around Z. We'll see if we can get it to go concentric. And then rotating around, go coincident. Alright, so as far as the interference then, let's see, that was to the cover. So we'll go back and show. So that's pretty far in. So let's go back to the section view and get a kind of a sense of where it's at. Yeah, it's still going to contact pretty close into the cover. So that being the case, what do we have for a gap? Well, I don't think that I can measure. Well, we'll try it. So if I go from the dome to the flat, and we go back to evaluate and measure, then a distance of 0.39, but that's kind of along the edge. What about the maximum distance? Well, that still went to 0.39. Can't say that I trust that number. Minimum's not going to help me center to center. So kind of a strange measurement. That would have been alright. Let's go ahead and open the spring back up. And configuration, item 18 is shown. We go ahead and add the configuration at the top level, 18, spring compressed. No, I did smaller than that. Helix, let's go to, well, that was probably a good, I know it was at least the 10 millimeters, so 1.125, I think it was. So 1/2 inch, let's see if it'll compress to 0.625 without it having a rebuild error. Okay, so since I went a little too heavy, we get to go back and do it again. And that's assuming I have the correct spring. But that is like full compression. Maybe even beyond full compression. Alright, so let's see where it goes to. So close, but either I have the wrong spring or we have an interference issue. If it's going to fully collapse the spring before the plunger can, while the plunger is making contact, or if it's supposed to make contact on top of the Philister head screw, that still doesn't make much sense to me. But pretty much at this point, spring is collapsed, and the plunger is not at a point where it can make contact. So we would have to resolve that issue by either changing the head of the plunger or picking a different spring. Alright, we've got the placeholder for it though. Let me just double check that I didn't miss the math somewhere. 937 overall. 625, 312. No, that looks good. So my correction has raised more questions than I really wanted to deal with. Alright, drill in place with, let's see, item 22 was the other one. No. And so that was with the slide, but we really don't know what's going in there. So that looks just like the clearance. So not getting a real good sense there. Doesn't show as a spring going through there. But it is part of maybe the pivot. And I think we got that one, we got that one. We got those. So we're running out of parts and we're running out of errors to check. Alright, so locate for dowel. 1/2 inch dowel, locate from the other piece. So, okay, that explains what goes in there. I don't know that I'm going to take it all the way to the dowels. We'll do some of the hardware. Well, let's see. We'll see how far we get. Alright, so my work in progress, I want to go back to the other display state, so everything is just shown. And now everything is visible. Okay, that one's still able to move. Alright, I think let's go ahead and save that. Rebuild and save. And we need to open up the top level assembly. Alright, so still some issues here. Alright, able to move back and forth. I haven't really achieved a distance, but if that's going to stay on the contact where it goes in, and I'm not, I don't think I can do the cam mate and have that contact. So staying in the center, pushing down at the same time that it's pushing back. That's kind of a complicated setup. So we do need to do the connecting rod as well. All right. So except for hardware, I'm thinking that we've got all the items. That'll be something that pops out at me here in a minute, but except for the connecting rod, I think we have all the items. So let's take a look at hardware. So we started the hardware with the Now, what was that thing called? Yeah, the slides and the block. And we changed those out to socketed cap screws. So that's all part of the mix. And then this whole thing is moving at an assembly, or as an assembly. All right, and then we have the whole locations to mount for the quarter 20s. All right. All right, so the drill in place, that locks those two pieces together. I can kind of see that. So when that's moving back and forth, then these guys, that still doesn't make abundant sense, but all right, we'll go with it. I'll do another quick check for the upper, and those were 3/8/16. So, all right. So back to the work in progress, and doesn't look like I'm going to be able to select that one. All right, so put it up there. All right, so the dowel pin was called out. I lost it again. Okay, there we go. Drill in place with 22. And for it to lock together, it really shouldn't need too much. So I have 20, there we go. 0.5 by 1.5 inch dowel. So we've located that one. And the slide locator, we will go back and show. All right. So if I go into the toolbox, notice the toolbox isn't selected. It tells me it's not active, so we're going to add in now, which is the same as coming up to add-ins, which is the same as coming up to options and add-ins, and being able to select those. All right, once it's added in, again, the toolbox is only available in the assembly. Otherwise, you're just opening its parts, looking at the various items. So let's open up a little bit more. We'll go into the pins, and all pins. Standard pin, clevis pins, hardened dowel pins. Let's just go with a regular dowel pin. I'm going to zoom up on the area, and we'll go to the edge. Maybe. So I found a 7/16. Okay, not quite. I was kind of expecting it to end up doing a smart mate. 1.5 inches long. I'll go ahead and position. Since it did not create the mate, then we can just go concentric and coincident. And that puts it in place. All right, this piece was 2 1/4 and 5/8 in diameter. So got at least a concentric out of that one. I was trying to pick the edge, which is often what we'll do with the socketed cap screws. So this goes to 5/8, and then its length. I got a 2 1/2, no 2 1/4. So let's see what it looks like. So if I go coincident, well, that sticks out the other side a little bit, maybe not. All right, so if I right-click and edit the toolbox components, it's going to put me back into that window where I can select. We could either try to go add it, or maybe 2 1/4 is something that I have to make. So that being the case, that 1/4 of an inch, I'm going to stay. I think there's enough engagement there, so I'm going to stay with the concentric, but the coincident is going to change over to a dimension. And I'm going to offset it to 125. Let's see, we're going to flip the dimensions so it stays interior. And now it's subflush. All right, is it really going anywhere? Well, at least not now. All right, so I would have to look at my manufacturer to decide, do I want to stay with that dowel pin if a 2 1/4 is available? Being that size, you're probably not going to buy those in packs of 100, maybe packs of 5 individually. So if it's available, great. If not, we will figure something else out. All right, so the 1/4 20 or the 3/8 then is going to be under the bolts and screws, and so we said we were going to update the hardware. Instead of the fillister head, we're going to go to socketed cap screws, and so we want a standard cap screw going to the edge, and as it finds, well, maybe not that one, 3/8 and then 3/8 of an inch long, yeah, not quite. So just kind of going into that hidden view, 1 1/4 looks pretty good, so good guess. Go ahead and stay with that one. And then it's going to stay in that that selection until I change it. So again, I'm kind of looking for that inside edge. And when I click on it, it's going to apply the concentric mate. It's going to apply the coincident mate. And then I go back to solid. It still seems weird that that is in contact. You know, it's going up, but you know, based on the function, I still just I'm having a hard time saying that that's going to go into full collapse before it contacts. Now maybe that's long enough that it's meant to be up just a little bit and push back, but somehow, well, until we get the connecting rod in there, maybe one of the configurations for assembly would be to make that tangent. Or not. Add this mate and over define the assembly, break other mates, or cancel, we'll cancel. So still interesting on that one. Let's look at it in section view. So I think I got everything into that one. So we'll get out of the section view, go ahead and save. Rebuild and save the document is fine. So another one on the list, we have to verify that there's not a 2 1/4 dowel pin, or we'll have to make one. All right, the movement back and forth. So there's not really a stop so much as this is able to hold it down as it rotates, and then it pushes it back. And then for the locator for the spring, well, you know, as much as that overhangs, I can see, I could almost see that keeping it from going any farther forward. Alright, so functionality is still in question. Alright, so what else did we miss? Okay, so let me put this in the video since we sort of resolved the question of the threads and the properties. I will just make quick mention that under the options and the file locations, that when we were putting the threads on the cradle, that with 2017 Service Pack 5, there is a thread profiles location, and this was previously pointed to SOLIDWORKS 2016. We need it pointed to the 2017 folder and updating the thread profiles. The other item of interest was the properties list, and it was under custom property files. And so same thing as SolidWorks 2016, when it was upgraded, the folder was either deleted or is no longer accessible. So we're having to update those to 2017. All right, and so where that shows up is under the properties. We go over to custom. If you go to add a description and this list is blank, it's pointed to some other location. Go into the options, go to the file locations, pick that custom property files, and point it to the list, or the list that you have currently. So description, and type in, okay. Type in for the fixture, it's evaluated 2. Now we have one item, one description related to that item. All right, I'm going to kind of collapse some of these. Let's see, let's show the sleeve. All right, so that was that piece. We kind of, okay, that was hidden because this had that interference. All right, and I'm selecting through the transparency. So I think on the drawing, either I missed it or did not pick it up as a diameter. That the radius of 0.886 was actually a diameter of 0.886, and so that's what made it smaller. So that may have been corrected. I don't know if that made it into the video or not, but it looks like it's contacting, well, it's contacting better anyway. So let's go ahead and show the sleeve. All right, so those come down in contact. Looks like there's a little bit of interference there. So I would want to check the dimension on the layout, because I can't have that coming down and contacting at the cylinder. So choices are that, yeah, I feel pretty confident that that was correct, which I'm not. Let's go back over to this one, 6.75 to the height. And then we had all of those items on center line, but because of this stacked on top of that, and we made the assumption that that was off of that, which was off of that, you know, and there's not a full dimension from that center line to the base. That's a little scary. I'm going to say it's probably not the 5.5, and given the problems that we ran into with the ramp and that piece, just because we have that chain of dimensions stacking up, that's still a little bit of a problem. So until we get the connecting rod in there, I'm hesitant to start making a bunch of changes. This could easily move down 1/8 of an inch, maybe 1/4 of an inch, and but then we're contacting the base. Or it's, you know, as it's rocking, we could move down, but now we're going to lose how much it's able to rotate. All right, so dynamic systems, and we start checking out these movements, we're going to have to decipher what's going on here. All right, so we got hardware there. Let's go ahead and open up the cradle. All right, so let's go ahead and bring this in. So the last 2 times I tried this with the threads, we had that issue. So I'm going to pick the leading edge, and under Hole Wizard, thread. Thread sizes are nominal and profile. So I have the edge. I'm going to go up to selection, which is going to be the face. All right, so it kind of goes 1 revolution past. But then the offset at the start, we adjust it, and it's going 100 thousandths in. So I want to reverse the direction. 100 thousandths out should be okay. But what I don't have is that this is picking up the 1.7512. And so the library feature part, and since I moved it, something moved. All right, we'll stop doing the roll on the roller on the mouse. And there is no 1 3/4 16. Do I want it just for reference that there's a thread there to make it look pretty, or do I need it correct? All right, so locating the profile, left hand or right hand, left hand, wireframe preview. So there's my 1 3/4 12. It does not specifically call it out, and we're not seeing it in the thread profile, but if I open it up, I'm going to create confusion that this is not a 16. All right, so the issue with the 16, let's go ahead and save, is that we're going to open that library feature part. And I know this is kind of a off tangent item, but since we located it, let's go ahead and pick it out, program data. And again, if you haven't shown your hidden folders, you probably won't see program data. 2017, and then thread profiles, and this would be an inch die. Dies create the external threads. That's what it's representing, and then the inch tap, if we're going to add something, that would be the internal. Open, oh, because I probably just added that one, it's not going to let me save it now. Alright, so we will go for preference. None of these are equations. So that tells me that size-wise, if I go in and I add a configuration to the list, the 1 3/4 16, I would be able to modify. What I don't have, or what I would have to explore, is how they generated this geometry. So on the thread profile is just the sketch, and then they're performing the sweep. So we could calculate that would go from 083 to 0625, and then we would have to look at the ratios, profile heights, and profile lands to come up with new values for the 16 threads per inch. All right, so it's doable, but we're going to have to invest a little bit more in it to make it work. All right, so leave the 1 3/4 12s for now, and when I get a chance to experiment with it, we'll take it a little bit further. All right, and then on the other side, it's already got the lock rings over it and the preset, so probably not that big of a deal. All right, we're going to go back to the dowel pins. All pins. Dowel pin finds the concentricity. I think that one's also going to be 5/8. And then a length, let's go with the 2.5. Either that or that one went to 3/4. So let's go ahead and place that one. And it picked up the concentricity, which is fine. Oh, a little bit wider. So 3.5. All right, so let's edit the toolbox component. And we do have a 3.5 in the library. Make that coincident. Same thing here, edit toolbox components. Go back into the list, 3.5. All right, and then we'll jump back over here. Maybe to that one. Okay, so that thread, so 1/2 inch, so we went to the 1/2 13. Oh, I grabbed the wrong one anyway. I was looking at the base, not the cradle. Alright, so still not finding it. There we go. Alright, so 3/8, so 3/8 16. Just want to be able to verify it before I place a set screw in there. Alright, so socket set screw. And then because this is going to that contact, we have that little weird relief. Choice is going to be, do we go with a cone point, a cup point, a flat point, or the half dog? All right, so something makes me think that it's probably going to be the cone point because of the way it's pushing down at the same time that that angle is it's kind of facing up. All right, so 3/8/16 for the length. Let's start off at 1 inch so that we can have a pretty good sense of what it's doing anyway. And no, I don't need another one. We will look at it in section view. And as I bring it up, alright, so does it hurt anything for it to be sticking out a little bit? Probably not. But based on the, we need to, we double check that geometry. So that's going to kind of push in. I don't know, it might be better with the cut point. I'm thinking that, this is designed to kind of pull this down as, rather than letting it up. So cone point, if I drive it in there hard enough, it's not going to move at all. So decision time, let's go ahead and make it subflush. I'll change it to 3/4. A little cleaner look. And we'll go ahead and accept. And then to actually be able to position it, okay, if it'll let me pull it out. No. Alright, let's go ahead and rebuild. No. Let's see, so socketed cap screw, or set screw. We have the concentricity, but it should still be able to move. So since it's not cooperating, we will highlight it, go back over to the assembly, tell it to move, and then it will have to come up. So if I select that face and I select that point, then coincident, that'll be the contact point. Alright, so another note for future reference, the 1.75 by 16, we still have to resolve that. And because I put that, let's just say that I wanted to change all of those over to the 1" 12. We had the threads, we picked those up as a, there's the 1 3/4 16 as a tapped hole with the hole wizard item. Let's see, did we do? I guess we did that on both of them when we added it. So let's just suppress that one out real quick. No, let's not. So we lost the cosmetic thread, or the hole wizard item by suppressing it. Let's just see if we can add the thread form on top of it. All right, so our nominal, up to selection, and it found the 1 3/4 12. It's not showing me a preview. I'll need the selection, so let's bring it out the other side. And it doesn't really come far enough up. Cut thread on cylindrical surface, use extrude thread instead. Shows me the preview. That's another one of those fun, what? Alright, type is going to be an inch tap. Alright, it's an internal. So it finds it as the 1 3/4. Did it reverse the profile? I thought I saw it reverse the profile. Okay. So the offset is because it terminated before it ran off the part, and probably pretty close to the same. It completed that one. Then we would want to turn the offset on, reverse the direction. Again, 100 thousandths brings it up pretty good. And then we can save it. Okay, so what the threads are not going to do, let's look at it. And this is, we're really not going to get an alignment as I rotate or we lock rotation. It's not a given that there's going to be a perfect match between the internal and the external threads. They're there for reference. Okay, so it gives us something. What else are we missing? We had those. Did the spring stay in, or did I lose the spring? We got the plunger. I'm not seeing one of my springs. So that being the case, let's go ahead and hit the tab, and we can get rid of the cradle temporarily. We'll insert the component. Existing springs are still open. And was that item 30? Thought we had a measurement on that one. Oh, we may have had a measurement on that one to the contact point, not necessarily to the part. So concentric. All right. And I know it went somewhere. Where did I lose it at? So we can kind of see it in there. If we can grab it, we can move it. All right. So picking another spot. Well, if that gives me an edge or a location I can go coincident to. So being imported, it has that split line kind of thing going on. I'm okay with that. I wouldn't expect to see that in a native file, but that gives us something to work with. So if it wasn't, instead of the edge, I would try the face and the edge and see if those could come up coincident as well. All right, so we need to, and Shift Tab will bring the items back. All right, so my lofted base, I didn't really come back and refine that one, and we're kind of at a level that we should, we got the pin in there, and I don't remember if I decided. Okay, well we're at the sub-assembly level, so let's go ahead with the hand lever assembly. And back to the pins. What was the diameter? So 0.81 on the radius. So back into the pins, we'll go with the dowel pin. And that should have been a 1/8. Or not. So do we have a 1 5/8? 1 3/8 is about the longest. So that'd be something else that we'd have to look at. Alright, so that diameter, so that was the 7/32. Alright, so edit component. Yep, not going to be in that group, so let's go ahead and edit the toolbox components. And we're not going to pick up the 7/32. That is kind of a strange dowel pin. 625. All right. So, question being, is it readily available? Maybe not. The end face being flat, let's go tangent because it's going to flush it out and then go all the way through. All right. So one more piece of hardware out of the way. The mounting hardware are four or five items here. Not sure entirely that I'm going to worry about those. Let's see, that one's being shown. Okay, so there's the thread and the body. And we had all of those hole locations. So not a 1/4 20, 5/16, 18s. Alright, so since that picks up, we're back to socketed cap screws, maybe. Looking for that inside edge, no matching size. I got pretty close for not being able to find it. Alright, 5/16, 18. And then we need a length. Thread length. Oh, there it is. It's not a shoulder. Let's go 0.75 and see what it looks like. All right, so since that's in transparency and I go to the front view, almost bottoms. So I don't know that I would stay with the 3/4, but we'll go ahead and put those in. Just that it's really tight to the bottom, and we're already, well, we're a little bit over 2 times the diameter of the thread, so we've already got good engagement. So let's try to do all 3 of those, and right click, and edit toolbox components, and instead of 3/4, we'll back it off to 2 times D, 5/8. Alright, so still some room at the bottom that have decent thread engagement, and we're losing a little bit for the through hole, so 0.75 might have been a little bit better. But I really don't want to bottom or have it be too close to the, either that or we'll make the tapped hole a little bit deeper. Alright, on these guys the threads were interior. So let's highlight the slide and locator, show, socketed cap screw, and it went to 1/4-28, so it's pretty consistently finding the fine threads. Let's check the engagement, length of 1 inch. I'll let it go through. That's a fairly small thread for that big piece, so a little more engagement won't necessarily hurt. Alright, one more set screw, and like I said, we're going to kind of bypass these guys for now, find out a little bit more about what they do, come back to it. And then one of the problems with this being a transparency, trying to select is going to be kind of an issue. So the body, we'll come back and turn off the transparency long enough. And we had another one of those set screws, so socket. I'm going to stay with the cone point. And again, 1/2-13. I think we did the last one at 0.75 ultimately, so we'll go ahead and accept that. Nope, don't need another one. Find our point. And make it coincident. Alright, so with hardware, a little bit of dynamic motion. Oh, would help to turn that one back on. And so at this point, all we're really missing is the connecting rod to see what it does. All right, so our overall list, maybe we have 6 items that are still outstanding that need to be corrected, but we have enough to go in and say, if we wanted to do design for manufacture CNC, are we going to move away from the casting? What is the actual function of this assembly, this fixture? We have a good start to start making those decisions.